All right, ladies and gentlemen, this is our third presentation in Unit 5. And this week, what we're going to be talking about is what happens when matter changes. All right, so leading up to this point, what we've been talking about is how do we describe matter via physical and chemical properties, and then looking at the two different types of categories of matter, which was mixtures and pure substances. We're now going to take those mixtures and pure substances and we're going to do stuff to that. We're going to add chemicals to them, or we're going to do certain things to them, and we're going to see what happens when that matter changes. All right, and what we're going to find out is that matter can go through two different types of changes. So we're going to use what we've learned in the last 2 weeks to help us figure out whether or not an item will go through a physical change or whether or not it went through a chemical change. Okay? All right, let's get started.
Okay, so first one we're going to talk about is what's called a physical change, right? And it's basically what it just sounds like, in the sense that there is a physical appearance that has been changed, but the key part is that nothing new was created, right? So in other words, paper, right? Let's say I cut paper. I've now changed the appearance of paper, right? It's smaller, or maybe if it was a rectangle, now I made it into a triangle. But the biggest thing is it's still paper, and that's what a physical change is, right? I haven't created anything new. Like, I can still say that it's paper. Another example is chopping wood, right? If I go and I cut a piece of wood, if I chop a piece of wood in half, yeah, I made it smaller, but it's still wood. I can still say it's wood. It still has the same physical and chemical properties. All right, so that's the other part, is that the chemical properties of the substance does not change. So in other words, if the object was flammable, it's still going to be flammable, right? And same thing, and I didn't really write this, it's not exactly perfectly true, but also the physical properties, right, does not change that much either. All right, I'm going to put physical properties, right, equals, that's terrible, equals no change. All right, and when I say that no change, like the big stuff, like the density of the object still doesn't change, the color of the object doesn't really change, um, you know, but again, some of the physical properties will change in the sense of, like, if I cut a piece of paper, the size of it changes. The weight is going to change a little bit, all right, just because now I'm dealing with a small one. But in reality, it's still like the physical properties of it, like the melting point still doesn't change on the object. The boiling point of the object doesn't change because it's still the same object. It's, like I said again, it's only changed in appearance. All right. So how do we know when matter goes through a physical change? So here are a bunch of different clues that can tell you. All right. The number one question that you should always ask yourself is this. All right. And I'm going to say this over and over and over again in class is a change reversible? And when I say reversible, meaning it's really easy to change that. Like, for example, if I melt an ice cube, it's pretty easy for me to reverse that and make it back into ice. All I have to do is take that ice, right, and put it back into the freezer, and I get that. All right. So first question you should ask yourself is, can I undo that? Sure. If I cut a piece of paper, I can really pretty much put tape to put it back together. Okay, and it's still one whole sheet of paper, right? Other ones, they're usually pretty boring. Physical changes, like if I cut paper in front of you and said, "What is this, a physical change or chemical change?" You're gonna be like, "Ooh, wow, Mr. Zane, that's great. That was really exciting." It's not that exciting. All right. Some are, and I'm going to show you some that are going to be exciting. That you might think, "Oh, is that really a physical change?" But it is, right? Sometimes, like I said again, appearances change. And when I say appearances change, usually it's like the size of the object may change. Again, if I cut a piece of paper, I'm changing the size of it, right? Another one is matter changes states. So meaning that it will go through a phase change. Okay, so I'm going to put phase change right here. So in other words, if an object, like right here, if an ice cube melts, or if I boil water, right? Again, those are a physical change because I can clearly reverse that. Water's still water. Whether it's ice form, it's in a solid form, or whether it's in a liquid form, water's still water, right? And last thing, and this is the hardest one for a lot of kids to think about, dissolving is a physical change, right? When I put sugar into water and I dissolve it, it's sugar water. It's still sugar, and it's still water. They didn't chemically combine together to create something brand new, right? Sugar water is exactly the same thing. Again, I can easily reverse that, just like last time, is I can evaporate the water, right? And I can get my sugar back, right? The sugar will look exactly the same. It might be a little wet when I get it, but it's the same thing. So when I do all that, like so last week when we did all those mixture separation techniques, all of that are physical changes, all right? When I filter, when I do magnetism, when I do hand picking, when I do evaporation, all of those types of separation techniques are all physical changes, right? So whenever you see something like that, those are clearly physical changes. All right. So the second part is a chemical change. This is where now this is like the chemist. This is where we start getting into like chemistry. All right, where we start talking about when things change into something brand new. Right? That's what a chemical change is. So in other words, what happens is the object is no longer exactly the same as when you started it. All right? So we can say that both the chemical and the physical properties of the substance is now different. So for example, if I had sodium, right? And I'm sorry, let's say I had a piece of wood, right? And all of a sudden I go and I burn it. I no longer have wood. I now have ash, which is totally different than what wood is. So like its characteristics are different. For example, it's not even brown. I mean, it's blackened now all of a sudden, right? When I touch it, feels so much different than ash does. Ash feels flaky. Um, Wood doesn't. Wood feels very, very solid, and so on. Ash is not flammable, while wood is. So like, there's all these different little things that start to occur, right? Same thing, like if I have a picture of sour milk, right? If milk goes bad, what do we get? We get a different odor that happens. It starts feeling different because now it's starting to get chunky and so on. So like those are the things that we're talking about. It's now different because chemically that object is completely changed. All right, it's no longer milk anymore. It's sour milk, um, and so on. All right, and now here are some clues to tell us that a chemical change occurred. All right, so the first question, just like we would ask for physical change, is it reversible? And the answer to that question is it's irreversible, meaning it can't be reversed, or is very, very difficult to reverse. All right. So, for example, table salt. All of us know about tables, like a lot of us eat table salt and so on. That's sodium element and chlorine element that are combined together to make sodium chloride. That's table salt. All right. It is very, very difficult to make sodium and chlorine back into its, take to separate those two apart and make sodium regular and chlorine that we used to have. All right, so it's very, very difficult, or you can't do it at all. All right, so that's the thing that you have to ask yourself: can I reverse this? All right, other things. Usually, when you see a change in color, that's a pretty big giveaway. For sure, if gas is formed. In other words, if there's fizzing, foaming, or bubbling. Now, some of you guys might say, well, isn't when water boils, isn't it bubbling? Um, Technically, yes, in the sense that there's bubbles because there's air bubbles being made, but it's still water. And that's the part that you have to ask yourself. So, like, when you see the fizzing going on and stuff, you have to ask yourself, is that still is that still the same thing and it's just going through a phase change, or am I actually creating a gas? All right. Another one's energy is being released. So in other words, the temperature changes. All right. So it can get really, really hot, or when energy is absorbed, it gets really, really cold, or it doesn't even have to get really, really cold. It's just that the temperature changes and you don't even have any equipment. So in other words, I don't have a Bunsen burner or anything like that. When I pour liquid into something else, and if I start feeling that it's getting hot or cold, I know that that's a chemical change. Or if it gives off light. Anytime you give off light, that is a chemical change. All right. The odor changes. We talked about milk going bad creates an odor. All right. If it smelled good to begin with, and all of a sudden you mix two chemicals and you get this nasty smell, you should tell yourself right away, clearly there was a chemical change. All right. And last one, this is a little bit, a lot of you guys have probably never heard of this. It's called precipitate. All right. This happens quite a bit. It's when you take two liquids and when you pour them in together, you create a solid, all right? Which is to me, that's a very, very cool phenomenon that when that happens, and you will be doing an experiment that does something like that. And when you see it, hopefully you'll enjoy it. But yeah, it's pretty cool when you can take two liquids and then when you pour it, you just get this solid that gets mixed. So like these are just some of the observations. These are a lot of the observations. So when you mix chemicals together, when you see these things happening, it tells you clearly that a chemical change occurred and that now the chemical properties, right, and the chemical is actually changed into a different chemical. That's the reason why it's called a chemical change. All right, so this is what I want you to do. There is a link on my website. So if you go to my website, there is a part that says physical versus chemical change identification practice. I want you to go to that and I want you to practice. So it'll take you to a link where you can practice a little bit identifying whether or not it's a physical or a chemical change. All right. Once you are done with that, on the next slide here, there are 7 different videos that I'm going to have you watch. All right. Based on those videos, here's what I want you to do. I want you to make this chart, all right, in your notebook. I want you to first tell me during that video, as you're watching it, is that a physical or a chemical change? And then give me your evidence to prove that it was a physical or a chemical change. So, for example, oh, it changed color, it started bubbling, or it's reversible. Like these are the things that I want you to write to tell me whether or not a physical change happened or a chemical change happened. And this should say chemical change. This is terrible. All right. So it should say chemical change right here. Okay. And that is, and then once you finish writing all this stuff and watching all the 7 videos, that is the notes for this week. All right. Enjoy.